So if there's a point above and a point below our x-axis, that means there's at least one root in between. I'm just re-saying it because I forgot to hit the start on the record. Yes, sir? If they're both positive, that means, does there have to be a root in between? No. There could be. Absolutely, there could be. But there doesn't have to be a root. So it's only if one's positive and one's negative does there have to be at least one root in between. So if they're both positive, I don't know for sure that there's a root in between the two.
So what would we do if there was?
Then we can say that we don't know for sure that there's a root in between. We can't prove it. That would be a really good counter proof. Just pulling out a little geometry proof termage. Oh, snap. We're not doing tons of proofs. Like, no. Okay. So the questions for this look like this. Use the intermediate value theorem to show that f has a 0 between a and b. So we're given a is 3 and b is 4. What we need to do to prove there's a root between them is to do f of a and f of b. So we're going to substitute them in and evaluate them. So we're going to use the intermediate value theorem to say it at the end in like a sentence. I know. To be fair, I will not judge your grammar or spelling.
I want to make a point to have the worst spelling.
If I can understand what you intend, we're good. They've done studies on it, and pretty much if you have the first letter and the last letter right and contain the right letters, no matter what order they're in, you can usually figure out what a word is supposed to be. First letter, last letter, and has them.
Or like, you ever done those puzzles where they take out all the vowels?
Uh-huh. Wheel of Fortune was my jam because I could do that. I could figure out what we intended from the blank spaces. All right, so we're going to evaluate. I was giving you a second to write because I don't have to write the function wrong. We're going to evaluate f of 3, f of a. And we're going to do that by substituting in. I'm being very careful so that y'all don't complain to me again. To complain to Miss Hannah. I was like, y'all got real grumpy with me when I say plug it in.
Yeah.
And I talked to Miss Hannah about it. She laughed really hard. Because I went, my DC Precal kids gave me such grief about it. She's like, what'd you say, plug it in? I went, yeah. And she laughed. Because it was like parent-teacher night the day after we had that conversation last time. Oh, sorry. I did not lock this out so you could see the whole thing. You guys are stuck with my zooming in.
She'd say that like all the time.
Huh?
She'd always bring up like a toaster if you said plug in.
I think she did say that to me too.
She'd be like, are we talking about toasters?
Yeah.
And like, yeah.
I was genuinely mildly confused when she talked about a toaster when we had that conversation. She's like, yeah, did they say something about toasters? I'm like, not that I can recall. But she laughed. She thought it was funny. All right, so what do we get here? Because remember, we're doing this without a calculator. Not 9. Okay. I was just making sure. We can do this in pieces. Like, you don't have to jump all the way to the end. I agree with you. So finish simplifying it. F of 3 is what? It is -2. We're going to do the same thing for F of 4. Same vibe, different flavor. Oh. Huge. So we're going to substitute in that 4 and do the same thing. Do the same thing. So I heard things whispered. I heard 64. Minus 64. Plus 12. Minus 2. I don't know why we're whispering, but we are. It's okay. I don't know. Somebody else started it. I just kind of ran with it. It's okay. I can do a pretty decent stage whisper, so y'all can hear me. It's okay. We can whisper really loud. It is indeed 10. You're right. See, I don't know why, but when you said it's 10 in my head, it jumped to, it's just 10. I don't know. Because my brain is mildly broken, but that's okay.
Oh, SNL did a Ken thing.
Oh, I saw.
Right?
I saw. It was all over my TikTok.
I love how it's like, I didn't watch the episode.
Oh, God, no. I don't stay up that late. On
We
purpose.
don't watch it live. We just watch it a couple days later.
Oh, yeah.
What do you mean?
I don't stay up till 11:30 watching TV. Honestly, I don't think my TV's turned on anything other than video games in like 2 years. All right. So what we have here is we have our evidence. Since f of 3 is negative and f of 4 is positive, that means if I was to sketch these out, like if we were going to make a graph, you don't need to make the graph, but we can. When x was 3, my y was -2. I'm going to use pink because that one we did all pink stuff. And when x was 4, my y was 10. That means somewhere in between 3 and 4, we have a root. Ta-da! Proof. I estimated my x is 3, my y is -2. My x is 4, my y is 10. They have at least one root in between them. It could be like this. It could be like that. They could have 5 in between. They could have like a swoop situation. We don't know what's going on in between them, but that's what we're showing. We are proving this. So here's our like actual answer. Since f of a is positive, or no, f of a is negative. Since f of a is less than 0 and f of b is greater than 0, there, not the, exists a point, I'm going to run out of space, between, with an E, A and B, where f of x equals 0. Bless you. What's up?
This whole essay we got right?
Dude, it's a single sentence. And if you get the point across, no, but that's the mathy way to write it. Since f of a is negative and f of b is positive, there's a point somewhere in between a and b where f of x is 0. There's at least 1 point. And it's a single sentence where spelling doesn't count and grammar is construct. So get the point across, and I don't really care what order you put it in.
First question like this,
The first question on the homework is just like this.
so you plug these.
Yep. Substitute them. Yep.
Like the final result.
That should be your final answer, yeah. Since f of negative 3 is negative 3. F of negative 2 is positive 5. Somewhere between negative 3 and negative 2, there's a 0. They plugged it in, yeah. They substituted it in.
And we just do the same thing like that we did.
Just like that.
Oh.
Yep. We're going to do it again to practice it because wordly-wise, it's a little weird. But it's the same vibe. Sometimes they're not even going to give you whole numbers. Sometimes we have fractions and they're gross, but that's okay. Here's round number 2. We have 2x to the 4th plus 3x minus 2. We're given an a of 1/2 and a b of 3/4. Say yummy. Okay. Rock on. Okay. So just like we did last time, we are going to substitute these in. My a of 1/2. We're going to do f of a. F of 1/2. Two times 1/2 to the 4th. Plus 3 times 1/2 minus 2. What is 1/2 to the 4th? Not 2.
1,
Nope.
4.
1/16.
1/16. 1/16 times 2. 2/16, also known as 1/8. How about 3 times 1/2? 1.5 or 3/2 minus 2. Do we actually care what number this is going to wind up being?
No.
Is this going to be positive or negative?
Positive. Negative. No, wait.
Wait.
Negative.
Yeah, negative.
Negative. I was waiting for a consensus to happen in the in the comments. So it's positive, negative. Yeah, so this is going to be negative. So f of 1/2 is less than 0. We can tell that right here. It's because this is a teeny tiny bit, 1.5. Those do not combine up to be 2. When we take away 2, it's definitely going to be negative. Okay, so we don't actually care about the total value. If you want to get all the way down to the final value, totally fine. Totally fine. But we don't really care. We just know that f of 1/2 is less than 0. So let's do our 3/4. Similar vibe. F of 3/4. 2 times 3/4 to the 4th. 3 times 3/4 minus 2. All right, let's work towards simplifying this. I'm going to keep the 2 out in front. 2 times. What is 3/4 to the 4th? Yeah, because it's 3 to the 4th. 81.
Oh, yeah, that calculator.
Over 4 to the 4th. Big. A really big number. It's actually 256. Yeah. If you ever wind up working with binary, you'll be able to do that math in your head pretty fast. You can actually do it on your fingers in binary. Count binary in your fingers. Zero, 1, 2, 3. It counts in binary. You can count binary in your fingers. It's a trick I'll show you later. You don't need to, unless you are programming computers manually. Binary. I tried to make it catch on when I was in high school because when you count to 4, it is just a single finger. But I was, y'all's age.
You tried to make it a trend.
I did, because count to 4 when we graduated in 2004 was just a single finger. And to make it relevant. All right. 3 times 3/4. 9/4. Okay, I'm going to ask you guys a really silly question right here. What's 9/4 minus 2? 1/4. So I have 2 times this hot mess. That's an 81, not an 18. 56. Plus 1/4. So do we really care about what number it is? No, I know this is positive because both of these numbers are positive. So f of 3/4 is greater than 0. Because I took 9/4 and I took away 2. So that was our only subtraction. So everybody down here is now positive. So since f of 1/2 is less than 0 and f of 3/4 is greater than 0, somewhere between them is a 0. There exists a point between 1/2 and 3/4 where f of x equals 0. So it's using that intermediate value theorem that we wrote from that very, very first page. Fill in the blanks with what our A and B were. Then there must be a point between A and B when f of x equals 0. There must be at least one. There could be more than one. I doubt it since they're so flippin' close together, but it's possible. There must exist a point between 1/2 and 3/4 where f of x equals 0. Sorry, I know my handwriting is terrible sometimes. Oh, that I can change. Boop. Boop. Better? Sweet. That's how much I zoom it in, and even then my handwriting looks like that. It's awesome, huh? Okay. Ready for me to change it?
That's what
All right. So we're going to do some more of the sketching stuff like we did yesterday. This one has an additional step for us, though, because I'm not giving it to you in factored form. Since I'm not giving it to you in factored form, what are we going to need to do? Factor it! Yay! Let's see, did I lock it back out so I can zoom in? I did. Yay. So when we're looking to factor this, what are we going to do first? Yes. Yeah, you can put a 0 on the end. And factor by grouping, but it's going to be really annoying. Because what should we do very, very, very first? GCF. What do they have as a great common factor? X. But since my A term is negative, what should we take out instead of just X? Negative X. So I'm going to put it way over here. So we're going to have our f of x, opposite of x, leaving us with x squared minus 3x minus 10. Oh wow, I zoomed that in really far. That's quite tiny. Since this is an x squared, we can use our x frame. Minus 10 minus 3. What's my pair of numbers? Multiplies me negative 10. Adds to make negative 3.
Negative 5 and 2.
Negative 5 and 2. So we have our minus x out front. X minus 5. X plus 2. So we're in our factored form. So now we're going to find kind of all those same pieces we found yesterday. We're going to find our degree. We're going to find our leading coefficient. We're going to find our roots. We're going to figure out the positivity. We're going to figure out our end behavior. Getting the right letters in there. So let's start with our degree. What is the degree of the polynomial? 3. It's easiest to spot in the OG. It's our exponent, the biggest exponent. What is our leading coefficient? -1. So to find our end behavior, are we going to be looking at evens or odds? Odd. And is it going to be positive or negative? Negative. So then as x approaches negative infinity, f of x approaches what? Positive infinity. As x approaches positive infinity, f of x approaches negative infinity. So that tells me left arrow up, right arrow down. I tend to just kind of draw them on like that. It doesn't matter how pretty your arrows are. I just know the left side's up, right side's down. Where are our roots or zeros?
And 0.
0, 5, and -2. We can tell that from our factored form. So then we're going to do our positivity. That's where we do the little table looking thing. I need to make sure I have space for f of x on the bottom. 1, 2, 3. Oh, glad I gave myself more space. Because we have this x out in front, this guy. Okay, so we said each of these terms equal to 0 to find our roots. So we're going to need to use our x plus 2, our x minus 5, and our opposite of x. And we're looking at our roots. Ooh, I did not give myself enough space there. I'm going to change that line. There we go. -2, 0, and 5. I put them in order, smallest to biggest. So if x is less than -2, is the opposite of x going to be positive or negative? Positive. If it's between -2 and 0, is the opposite of x positive or negative? Positive. If it's between 0 and 5, is the opposite of x positive or negative? Bigger than 5? Negative. So then we're going to do x minus 5. If x is smaller than -2, is this segment positive or negative? Positive or negative is between -2 and 0. If it's between 0 and 5, positive or negative? Negative. And if it's bigger than 5, positive. Same thing for x plus 2. If it's smaller than -2, is it positive or negative? Negative. If it's between -2 and 0, positive or negative? So think about -1 is between 0 and -2, right? -1 plus 2 is positive. So when in doubt, pick a number and substitute it in your head. Okay, if it's between 0 and 5, positive. And bigger than 5, positive. So then what we're going to do is we're going to look at when we combine these together, when we multiply all these together, is our function positive or negative? So if our x's are less than -2, is our function positive or negative? Positive. What that means is that left of our point, our function is above the y-axis. Between -2 and 0, is our function positive or negative? Negative. That means between 2 and 0, our function is below the x-axis. Between 0 and 5, is our function positive or negative? Positive. So between 0 and 5, it is above the x-axis. Maybe it's real tall. Boop. And then when it's to the right of -5, is it positive or negative? Negative, meaning it is below our x-axis. So we have made a sketch. Your sketch may look slightly different. Maybe you didn't take your positive quite as high. Maybe you took your below on what I did as my red segment significantly lower. It's a sketch, not a true graph. We don't have the information about where it turned for those relative minimums or the relative maximum. We don't have that information. Maybe this segment on the side does something like this. Maybe it's all kinds of wonky and weird. As long as it doesn't cross the x-axis again, because we already have all the number of roots that we have. Okay, so creative expression. You can go wiggle squiggle on these guys. You could go wiggle squiggle on these guys. As long as you don't add more x-axes or x-intercepts, you're fine. Okay, let's do another one like this. Oh, not this one. That one was super duper gross. So this one has lots and lots and lots of pieces. It's all of a sudden like 1,000 degrees in here. Yes, I am boiling. All right. So we're going to sketch this polynomial. So it's already in factored form for us. We love that. So what is our degree? What was it? Not 2. How many x's are being multiplied together? 6. I have x squared times x squared times x. There's 6 x's up there. I'm spinning something. All right, what is our leading coefficient? 1. So for our end behavior, are we going to be looking at evens or odd? Even. Positive or negative? Positive. So as x approaches negative infinity, oh, sorry, not f of x. This is r of x. R of x approaches positive infinity. As x approaches positive infinity, r of x approaches what? Positive infinity. So my left arrow points up, my right arrow points up. Kitty ears. Then we're going to find our roots, or our zeros. Where are our roots? 0, -2, 1, +2. So we know we have roots at 0, 1. I don't like this graph having numbers on it. You know what I'm going to do? I'm just going to do this. And we're going to white out the numbers so that I can actually space stuff out and have it not be super gross. There we go. Imaginary numbers now. Or not imaginary. Just ignored. 0. 1. 2. And -2. Much better. So then we're going to do our positivity table. So we're going to need to use all of our pieces. We're going to use our x squared. We're going to use our x plus 2. We're going to use our x minus 1 squared. And we're going to use x minus 2. And our roots are -2, 0, 1, and 2. Just making my little table here so that it's at least vaguely organized. Not f of x, r of x. All right. So if x is smaller than -2, is x squared positive or negative? Positive. X squared is always going to be positive. How about between -2 and 0? Positive. Between 0 and 1? Positive. Between 1 and 2? And between bigger than 2. Positive. It's always positive. How about for x plus 2? If my x is smaller than negative 2, is this positive or negative? Negative. If it is between negative 2 and 0, positive. Between 0 and 1. Between 1 and 2. Bigger than 2. Positive. Okay. X minus 1 squared. Positive. Across the board. Because it's been squared, it is positive all across the board. So then we're going to do x minus 2. Negative. 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 Positive. Okay, once we get the hang of this, we can fly through these tables. So this is one of those things we're going to practice. So then we're going to look at our function rule. Our function, if it is smaller than negative 2, is it positive or negative? Positive. Positive times a negative times a positive times a negative is positive. So left of negative 2, our function is positive. It's above our x-axis. Between negative 2 and 0, is our function positive or negative? Negative. So between negative 2 and 0, it's negative. How about between 0 and 1? Negative. Oh, no, I already did green. Let's do yellow. So it's going to go down. How about between 1 and 2? Negative. How about bigger than 2? Positive. Okay? This one had 2 double roots at 0 and at 1, and we can see that here, what's going on with our graph. What makes that happen is bounce. We will have one more kind of problems. We'll do it on Monday. So if you see one on the homework that you're confused by, it looks like this. Yes. I also post a PDF. So there will be one more kind of problem on the homework that might be confusing. We'll do it first thing Monday. So homework will be due Tuesday. Homework will be due Tuesday. Turn 4-1 in Tuesday. I'm going to put that up for just a hot second because y'all get grumpy if I don't put it up and you claim I didn't. Mwahahahaha.